Hi guys, we're continuing on 5A, section 5A. I want to go back to this page that we already did in the previous video, but I want to talk about finding the slope of this example at the bottom using the formula, because that's what we're going to be doing on the next page. So the formula for calculating slope is back up here, right here, and it is calculating the change in the y values from one point to the next over the change in the x values from one point to the next. So we call these points x sub 1, y sub 1, x sub 2, y sub 2. So for instance, this point right here, we can call x1, comma, y1, meaning he is our first point. And 7a is x sub 2, y sub 2. So the little subscripts, these guys are called subscripts, they indicate which point I'm talking about, the first point or the second point. Because when we use the slope formula, we have to start with one of the points and subtract the other one. The formula says y sub 2 minus y sub 1 over x sub 2, x sub 1. So if we go plug in our points here, y2 is the second y, he's 8, y1 is the first y, 2, x sub 2 is 7, and x sub 1 is 5. When we do this, we get 6 over 2, which reduces to 3 over 1, which was the slope that we actually calculated from the graph. So we're going to practice calculating the slope using the formula, as well as just looking at a graph and being able to understand the rise over the run. Remembering our horizontal lines have zero slope. If we rise from left to right, it's a positive slope. If we fall from left to right, it's negative. And if it's a totally vertical line, it is undefined because you end up with the denominator, the run, on the y-axis being 0. All right, let's move to the next page real quick. And let's talk about this. I'm going to get rid of that guy. Let's talk about this first problem right here. So remembering that the slope is rise over run, I'm going to write that over here. Slope is rise over run. And the way I remember it is you have to rise up before you can run. Rise up before you can run. So the rise is the numerator, the first thing you write, and then you can run on the x-axis. So if we plot these 2 points, -1 and 3, if I've got that in the right spot, it's right there. And then the second point is -5, 7. Now, automatically, if you connect this with a line, it's not too bad, you can see that your slope is going to be negative from the page before. It starts high and it falls from left to right. So our slope is going to be negative. And we are going to first do it using the just the rise over the run visually from the graph. So to get from this point to get from this point to this point, we're going to rise up 1, 2, 3, 4. Rise up 4. And we are going to run from this point to this point. We're also going to run 4, and the slope is negative. So you can consider the rise negative, or you can consider the run negative, depending on how you look at it. But it doesn't really matter because you're going to put a negative sign in front of the slope, and this is going to simplify to m is equal to -1. Let's do it using the formula now. Change colors, I'll come over here, and I'm going to use m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is my x1, y1. This is my x2, y2, or yeah, x2, y2. And we're going to start with the y's. So y2 minus y1, 7 minus 3. x2 minus x1 minus 5 minus a minus 1. Here you got to really be careful about your signs. So that becomes 4 over minus 5 plus 1, which is minus 4, and the slope becomes minus 1. I want to show you something kind of cool. This is the formula, and this is the formula that they introduced on the prior page, on page 2. But you could actually write it like this as well. M equals y1 minus y2. Instead of 2 coming first, you could do 1 coming first. But if you start with y1 in the numerator, then you've got to start with x1 in the denominator instead of x2. So it really doesn't matter which one you put first, but you've got, well, the y's have to be on top. The y's have to be in the numerator. But you can start with y1, then you must start with x1 in the denominator. You can start with y2, then you must start with x2. Let me show you how this plays out. So this becomes y1 is 3, y2 is 7, so 3 minus 7, over x1 is minus 1, x2 is minus 5, minus 1 minus a minus 5. This becomes minus 4 over positive 4. Negative 1 plus 5 is positive 4. So your slope is negative 1. So negative 1, and visually from the graph, negative 1. So we just about proved this about every way we can possibly prove it. Let's just do this example number 4, just using the formula. So if you plot the points, if you just take a look at the points, though, 1, negative 2, right here, and 6, 1, 2, 3, 4, 5, 6, negative 2, and you connect them, you see you're going to get a horizontal line. So from the previous page, we know that a horizontal line should have a slope of 0. This is what we're expecting. So we're going to prove it. So the slope, y2 minus y1, x2 minus x1. This is my x1, y1, x2, y2. Plugging in my values, I get minus 2, that's y1, or y2, minus 2, minus a minus 2, that's y1, over x2, go back to this one, 6, minus 1. So that becomes minus 2 plus 2, which is 0, over 5. Anything with 0 in the numerator becomes 0. So we have just proved with the formula that our slope is 0, and we saw it visually before we ever even began. This last example here, if we plot the points, 3, 1, 2, 3, 1, 2, 3, negative 4, and 3, 1, 2, 3, 1, 2, 3, 4, 5, and you can see that this is going to be a vertical line, and we're going to expect that we're going to have a slope that's undefined, but we're going to prove it. So let me get a different color. M is equal to y2 minus y1, x2 minus x1, y2 is 5, y1 is negative 4. Be careful with the signs. x2 is 3, x1 is also 3. You can see where you're going with this. This becomes 9 over 0. We cannot divide by 0, so our slope is undefined. Let's see, how are we doing for time on this one? Okay, I'll stop, and then we'll come back and pick up some more in the next video. Bye-bye. Thanks for watching.